In this episode, we're going to take a calm, practical look at why security becomes harder as cloud environments grow, and why the best long-term answer is not more heroics, but more repeatability. Cloud systems change constantly, sometimes many times a day, and that pace creates a simple problem. Humans are not built to remember every setting, every exception, and every dependency perfectly, especially when the environment is large. When security depends on manual configuration, you end up with invisible drift, inconsistent rules, and surprises that appear months later as incidents. Infrastructure as code, IAC, is a way of defining infrastructure using code-like declarations so changes can be reviewed, tested, and repeated reliably. The goal is not to turn security into paperwork, but to make secure configurations the default outcome of normal work. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful starting point is to understand what people mean by infrastructure in cloud terms, because beginners often picture infrastructure as servers and networks only. In cloud environments, infrastructure also includes storage rules, identity permissions, logging settings, encryption options, and connectivity boundaries, all of which are security relevant. When those elements are created through a web console by clicking around, you get configurations that are hard to reproduce and hard to verify. Even if a person does everything correctly once, repeating it across multiple environments, regions, or accounts becomes error-prone. IAC treats infrastructure definitions as a set of desired states that can be applied consistently, which makes security controls less dependent on memory and more dependent on controlled artifacts. When the infrastructure is defined in a repeatable way, security becomes a property of the system design rather than a hope attached to each manual change. At a high level, IAC means you describe what you want the environment to look like, and a tool applies that description to create or update resources. The description can include networks, access rules, and service configurations, which means it can include security decisions in a form that is reviewable and versioned. Beginners sometimes worry that using code will make security more complicated, but the opposite is often true because it makes changes explicit. A human clicking through a console can create a complex result without leaving a clear record of exactly what changed and why. A code-based definition creates a tangible artifact that can be examined by others and compared over time. That visibility supports both security review and operational troubleshooting, because the system's intended configuration is written down in a precise and reusable form. Repeatability is one of the most important security outcomes of IAC, because attackers benefit when environments are inconsistent. If every environment is built slightly differently, it becomes harder to know what is normal and harder to enforce policies. Repeatability means a secure network boundary can be applied the same way in development, testing, and production, with controlled differences rather than accidental ones. It also means that if a secure baseline is improved, the improvement can be propagated quickly and predictably. Beginners sometimes assume that once a secure design exists, the work is done, but cloud environments evolve, so the baseline must evolve too. When the baseline is code, evolution becomes manageable because you can update the definition and redeploy consistently rather than patching each environment by hand. Repeatability turns security from an ongoing manual struggle into an engineering process. Testability is the second major security outcome, and it is the one that transforms IAC from convenient to powerful. When security settings are expressed as code, you can test them before they are applied, which reduces the chance that unsafe configurations reach production. Testing can include verifying that storage is not publicly accessible by default, confirming that network rules follow least exposure, and checking that identity permissions are narrowly scoped. The beginner-friendly idea is that you can treat security expectations like acceptance criteria, and you can validate those criteria as part of normal change workflows. This is different from traditional auditing, which often happens after the fact, when the cost of fixing mistakes is higher. With IAC, you can catch mistakes earlier, when they are cheaper and less disruptive to correct. Testability makes secure behavior easier to enforce consistently. Another benefit of IAC is that it supports review, which is a security control in its own right. When changes are made through code, they can be reviewed by another person, and that review can catch risky choices before they become real. Review is not about distrust, but about reducing human error and ensuring that security considerations are not overlooked in a hurry. Beginners sometimes think review is only for large organizations, but even small teams benefit because people miss things when they are tired or under time pressure. When security-relevant changes are visible in a code change, they become easier to discuss and improve. This shifts security from being an afterthought to being a visible part of the change process. Visibility reduces accidental exposure. IAC also helps with auditability because it creates a record of what the environment is supposed to look like and how it changed over time. In manual environments, investigators often have to infer intent by looking at current configurations and guessing how they got there. With IAC, intent is embedded in the code history, which shows when a security rule changed and who approved it. This supports incident response because teams can quickly identify what changed recently and whether that change may have introduced risk. Beginners sometimes assume that logs alone are enough, but logs show activity, not design intent. Code history shows intent, and intent matters when you are trying to understand whether a configuration was deliberate, accidental, or malicious. Auditability strengthens confidence and speeds up troubleshooting. A common beginner misunderstanding is believing that IAC automatically makes everything secure just because it is code. Code can still be wrong, and it can still encode dangerous defaults if the team is not careful. The real security benefit comes from using IAC to enforce known good patterns and from surrounding it with review and testing. If your code defines a publicly accessible resource when it should be private, you have simply automated insecurity. Therefore, the discipline is to build secure defaults into the templates and modules people use. This is where the earlier ideas of default deny and least privilege connect naturally, because you want your reusable patterns to deny access unless explicitly allowed and to grant only minimal permissions. IAC gives you a way to bake those principles into repeatable building blocks. Reusable building blocks matter because most teams do not want every developer to reinvent the security posture of a network or storage system each time they deploy something. When patterns are shared and standardized, they reduce variation and make security review easier. Beginners sometimes fear standardization will slow innovation, but it often speeds it up because people can focus on application logic while relying on proven infrastructure patterns. Secure building blocks can include default deny network configurations, private connectivity settings, and logging that is enabled by default. When these blocks are used consistently, the environment becomes more predictable and less prone to accidental exposure. Predictability is valuable because it reduces the attack surface created by inconsistent configurations. Standardization turns security from a bespoke craft into a scalable practice. IAC also influences how teams handle secrets, because automation systems need credentials to create and manage resources. This is where the previous episodes connect directly. If IAC workflows rely on long-lived, broadly scoped keys, they become a high-value target and a potential attacker bridge. A safer approach is to use tightly scoped identities for automation and to prefer short-lived credentials where possible. The point is that automation does not remove identity risk. It concentrates it into fewer places, so those places must be protected. Beginners sometimes assume automation is inherently safer, but automation can amplify mistakes and amplify compromise if the identity behind it is too powerful. When you combine IAC with least privilege identities and reliable rotation, you get automation that is both efficient and defensible. Security becomes repeatable without becoming brittle. Another place where IAC helps is configuration drift, which is the gradual divergence between what you think you deployed and what actually exists now. Drift happens because people make manual changes during emergencies, because teams apply quick fixes through consoles, or because different environments evolve differently. Drift is dangerous because it undermines trust in your baseline and makes it harder to know whether policies are being followed. IAC provides a reference point for intended state, and it can be used to reapply the desired configuration when drift occurs. Even if the environment must change quickly, IAC allows those changes to be captured and made permanent in a controlled way, rather than leaving them as undocumented one-offs. For security, reducing drift means reducing unexpected exposure that can linger unnoticed. Drift control supports both stability and defense. It is also important to connect IAC to change control thinking without turning it into bureaucratic delay. Cloud environments move quickly, but quick does not have to mean careless. IAC allows changes to be small, reviewable, and reversible because you can see exactly what a change will do and you can roll back by reverting the definition. This helps teams make security improvements iteratively rather than waiting for large redesigns. Beginners sometimes assume secure change must be slow, but secure change can be fast when it is structured. The real enemy is untracked change, because untracked change creates unknown risk. IAC makes change tracked by default, which is a significant security win. As these ideas come together, you can see IAC as the mechanism that turns security principles into a daily habit rather than an occasional project. Least privilege can be encoded in role definitions, default deny can be encoded in network rules, and secure secret handling can be encoded in how automation identities are granted access. Because these elements are expressed as code, they can be tested, reviewed, and reused across the environment, which makes it far harder for insecure exceptions to slip in unnoticed. This also supports faster learning, because when something goes wrong, teams can examine the definitions and understand the cause rather than trying to reconstruct a sequence of console clicks. The environment becomes teachable, which matters for beginners because it reduces mystery. A system that is understandable is easier to secure. By the end of this episode, the central takeaway is that cloud security must be engineered for repeatability because manual precision does not scale with constant change. Infrastructure as code makes infrastructure definitions visible, versioned, and consistent, which reduces accidental exposure and supports secure defaults. It makes security testable by allowing checks before changes are applied, and it makes security reviewable by creating artifacts that others can inspect. It also improves auditability and drift control by recording intent and enabling consistent redeployment. When IAC is combined with least privilege identities, safe secret handling, and disciplined change workflows, it becomes a practical foundation for reliable cloud security. Instead of relying on memory and hope, you rely on repeatable patterns and observable changes, which is exactly how security stays strong as environments grow.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.